last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hi, welcome to today's class. Today we'll be looking at a topic called fundamental and derived units and quantities. At the end of this lesson, students should be able to distinguish between fundamental and derived quantities and also distinguish between fundamental and derived units. Now let's look at the word fundamental unit. What is fundamental unit? Fundamental units are the accepted units or measures in which measurement is what is the main. Examples are, we have meter, kilogram, second, ampere, Kelvin, candela, mole. These 7 stands as the major, in other words, the fundamental unit in science. Now let's look at derived units. Derived units are new units because they are derived from the combination of what? Fundamental unit. For examples, we have meter per second square, meter per second, and what? Meter cube. All of these are what? Just few examples of what? Derived unit. Now let's look at the difference between fundamental and derived units. For fundamental units, we have been told that they are what? Standard units of what? Measurement. Because all derived units are formed from the combination of what? Fundamental what? Units. And we say derived units they are not standard units of measurement. We also meant to understand that fundamental units are also known as what? SI units. You've come across the word SI unit. SI unit. SI is an acronym for what? System International, or the other way around, International System. They are known as what? SI unit, and derived units are just known as what? Units. Fundamental units form the basis of measurement in science, while derived units are not the basis of measurement in what? Science. Now let's look at fundamental quantities. What are fundamental quantities? Fundamental quantities are the basic quantities that provide the standard units of what? Measurement. We have, out of the 7 fundamental quantities, we have 3 main fundamental quantities, which are length, mass, and time. And these quantities form the basics for dimension of physical quantities, which we are going to look at in the preceding slides. Other examples of fundamental quantities are what? Temperature, current, luminous intensity, and what? Amount of substance. Now let's look at derived quantities. What are derived quantities? Derived quantities are quantities obtained from the combination of fundamental what? Quantities as a result of either multiplying these quantities or dividing these quantities. Examples are, we have numerous examples, but just to mention a few, we have velocity, acceleration, force, momentum, work, power, pressure, density, area, and volume. Now let's look at derived quantities and the units in terms of what? Their basics and their definitions. Now for physical quantities, we say area has the formula to be what? Length times breadth, and the symbol is what? A. What's the unit? We know it's meter per second square. All of this for volume, we know the formula for volume and the symbol and the unit, which is given here. For speed, for linear acceleration, for force, for power, for density, which is what? Mass over volume. Mass divided by volume, and the symbol is what? P. And what the unit is what? Kilometer per meter second square. Are we together? Kilogram per meter per second square. Now let's look at differences between fundamental and derived quantities. For fundamental quantities, we have been told that they are based on what? SI unit, which is also known as what? The International System. Derived quantities are formulated from international system. In other words, derived quantities are formulated from SI unit. Fundamental units are known as direct to have. They are known to have direct calculations. Why derived quantities? Their calculations are derived. Fundamental quantities are basic units of what? Measurement. Why derived quantities are not basic units of measurement. Fundamental quantities, they stand alone, while derived quantities, they don't stand alone. Now let's look at dimension, the subtopic under this topic. Dimensions of what? Physical quantities. What are or what is dimensions of physical quantities? Dimensions of physical quantities simply mean the way these physical quantities are related, connected, or associated to what? The fundamental quantities. And these fundamental quantities in question are the length, mass, and time, which are the three main fundamental quantities. They are represented as with the acronym L, M, and T. I will look at this in the slide. Now let's look at the summary of dimension analysis based on physical quantities we have treated in the previous slide. Now for area, now understand this. For you to get the dimension of a physical quantities, you have to break down the formula, and from the formula you will be able to derive the dimensions based on the three main fundamental quantities, which are length, mass, and time. For area, we say length times breadth, which is the formula. Now, how do we derive the dimension? You will see beside the formula length, you have L, which represent length, and breadth, and L beside breadth, which represent length also. Now, how are the dimensions of the physical quantities derived? They are derived by the application of what? Some of the laws of indices, which I believe you have treated in your math classes. One of the laws of indices, which says that if you multiply two, if you have two numbers which are similar, 2 times 2 can be also represented as what? 2 raised power 2, which is 2 squared. Same thing here, if you have two letters which are similar, you have them to be L times L, you multiply them to be also L squared. This is how we get dimensions. Now let's look at speed. For speed, the formula for speed is what? Distance over time. Looking at the formula here, you can be able to derive the dimension based on the formula given. For distance, it refers to what? Length, and for time, it refers to what? T. L over T will give you LT raised power minus 1 because of the division sign. This is a lot of indices which I believe you have treated. For velocity, it has simultaneously the same dimensions of speed. Looking at linear acceleration gives the formula as what? Velocity over time. Looking at the preceding column, which says velocity, the dimension for velocity is what? LT raised power minus 1. You impute that in the formula for linear acceleration, you have LT raised power minus 1 over T. If you apply the law of indices here, you get it to be what? LT raised power of what? Minus 2. For force, we say the formula for force is mass times what? Acceleration. You impute the same procedure for mass, it is what? M. For acceleration, looking at the preceding column for the dimension of acceleration, you impute it there, you bring it down, you have it to be what? MLT raised power of what? Minus 2. Same thing applies for work. Work is given as force times what? Distance. Force is given in the preceding column, which is MLT raised power of what? Minus 2 times what? Distance. You apply your law of indices here, you have the dimension to be what? ML raised power 2, T raised power 2. Same thing for power. Power is given as work done over time, and the dimension is what? ML raised power 2T. Density, same thing. Mass over volume. You understand that volume is what? Length and breadth times what? Height. You have 3 length in question. So if you apply the law of indices, you have it to be L raised power of what? 3. And if you do the math here, you have it to be what? And the math operation here, which is also apply the law of indices, you have it to be ML raised power 4 minus 3. Now here is a little practice questions for you to be able to assimilate better what has been taught in this lesson. We said the first one says name the 3 fundamental quantities in science and their respective units. The 2 says mention 7 derived quantities. And I believe at the end of this lesson you've been able to assimilate something and understand a little about fundamental and derived quantities and their units. Thank you for your time and see you in the next class.